Welcome to today's lecture on disk scheduling algorithm, which come under operating system. In this session, we'll explore the importance of disk scheduling and how different algorithms aim to optimize disk access. Let's start by understanding the basics of disk scheduling and its significance in enhancing the system performance. First, we see the disk structure, in which disk drives are addressed as a large one-dimensional array of logical blocks, where logical blocks are represented as smallest unit of transfer. The one-dimensional array of logic blocks is mapped into the sectors of the disk sequentially. So, sector 0 will be the first sector of the first track on the outermost cylinder. Mapping proceeds in order to through the tracks. What are these? We'll move to the next slide and I'll explain here. Here you can see we have multiple circular shaped disk shapes, which is called platters, and these platters are arranged sequentially, and in these platters we have tracks, and each tracks we have sectors. These circular platters are connected as a cylinder in which a spindle is there, which is cause the rotation of these platters. We have an arm assembly in which we have different arms. Each arm is connected to the each platter, and at the end of that arm we have read-write head. Now move to the forward on our topic called disk scheduling. The operating system is responsible for using hardware efficiently. For the disk drives, this means having a fast access time and disk bandwidth. Disk scheduling algorithms are crucial in managing the order in which disk I/O requests are serviced. One of the fundamental goals of disk scheduling is to minimize the disk arm movement and reduce seek time. The access time has two major components: seek time, rotational latency; transfer time, disk access time. Seek time is the time for which the disk arm to move the heads to the cylinder containing the desired sector. Rotational latency is the additional time waiting for the disk to rotate the desired sector to the disk head, where the transfer time is the time taken to transfer the data, and the disk access time is which is equal to rotational latency plus seek time plus transfer time. And the last one is the disk response time. It is an average of the time spent by each request waiting for I/O operations. Disk bandwidth is the total number of bytes transferred divided by the time between the first request of the service and the completion of the last transfer. Let's consider a scenario. We illustrate them with a request queue. We have 0 to 199, matlab total we have 200, in which there is a queue which starts with 98 and ends with 67, and the head pointer is at 53. So first algorithm is called first come first serve algorithm. Let's see, in this diagram we have 53 as a starter pointer where head starts. So in the first come first serve, we treat every first come element as a first serve, that is 98. So first we serve the 98, and then the next one is 183, and then 37, then 122, similarly 14, then 124, and then 65, and the last one is the 67. To calculate the total head movement, we have to calculate all the transitions, like 183 minus 53, because it is in the same direction, so we can get choose either 98 minus 53 plus 183 minus 98 or 183 minus 53. So similarly we can calculate them and the answer should be 640 in this case. So this is first come first serve algorithm. Move on to the next algorithm. Before that we see the advantages and disadvantages of first come first serve, in which advantages says every request gets a fair chance. Who come first, which will be served first. No indefinite postponement. The disadvantage is it does not try to optimize the seek time, because in the first come first serve we cannot handle the seek time or optimize the seek time, because every next element is we have to serve may not provided the best possible service. Next is SSTF, shortest time seek time first, in which we select the request with the minimum seek time from the current head position. This scheduling is a form of SJF scheduling, shortest job first, may cause starvation on some requests. Illustration shows in the next slide. We have the same queue, head start is 53. Now we'll check which particular next nearest seek time from 53 is available. That is 65. So first we have to move to the 65. Then next we have to see which seek time, nearest seek time is available. Then we have 67. Then after that we have 37. Then after that we have 14. Similarly basis we have to reach to the 183. So in shortest seek time first we have to check which element of the queue is nearest seek time from the previous. And the same in the same scenario we have to same way we have to calculate the head movement. The answer of the head movement will be here is 236 cylinders. The advantages of SSTF is we have average response time decreases, throughput increases here, and the disadvantage is rather you came first in the queue, but you have to wait until your chance has come according to the algorithm. So this causes starvation for a request if it has a higher seek time as compared to the incoming request. Now next algorithm is called scan algorithm. Here the disk arm starts at one end of the disk and moves towards the other end, servicing request until it gets to the other end of the disk, where the head movement is reversed and the servicing the continues. This is also called elevator algorithm. See the scenario. In the same queue we have a head start at 53, so we have to give the direction also towards the lower. So towards the lower side, so we have to move from 53 to the lowest to the end of the cylinder, means 0 is the end to have to, but between them we have to process every incoming request. So after 53 we have to service the 37, then we have to service 14 and then 0, and then now we move backward and service all the remaining requests as they come first. Means like from 0 we have first one is nearest one is 67, then 65, then 67, then 98, then 122, then 124, and the last one is the 183. And similarly we can calculate the head movement. Here the head movement value is 208. Advantages of this is we have high throughput and the average response time is good. And the disadvantage is long waiting time for the request for location just visited by the disk arm. Next algorithm is look algorithm. Here the disk arm traversing the disk surface to service requests efficiently. However, unlike scan, look doesn't go all the way to the end of the disk before reversing its direction. We can see in this diagram in here the direction is selected as towards the higher side. So we can take start from the head start of 53 and move towards the higher side, that is 65, 67, 98. We process all the requests until the last highest number. We cannot go to the 199 because it's not scan, it's look, because here we cannot go to the end of the disk. So after reversing the direction, we process the remaining called 37 and 14. So in this way we can schedule the disk in look algorithm. In the same way we can calculate the head movement here also. The advantages of look is it reduces the head movement where it does not go to the end of the disk. Fairness in the request servicing adaptive behavior. The disadvantage is here also the risk of starvation and inefficiency for bursty workloads. Next algorithm is called C-scan. It is a variation of scan algorithm. It provides a more uniform wait time than scan. The head moves from one end of the disk to the other servicing request as it goes. When it reaches the other end, however, it immediately returns to the beginning of the disk without servicing any request on the return trip. Treat the cylinders as a circular list that wraps around from the last cylinder to the first one. That's why it's called C-scan. C for circular. We see the same scenario here. You can see, like the scan algorithm, we move towards the highest value, okay, and when we reach the highest value we have to cover the end of the disk called 199, and at the reverse situation we does not serve any element until we reach the end of the another end of the disk, and after that we again reverse our decision as a direction, and then we treat all the remaining elements in the queue called 14 and 37. In this way the C-scan goes. The advantages of C-scan is it minimizes the head movement, it improves the throughput due to continuous scanning in one direction. The disadvantages is potential unfairness in the request servicing. Risk of starvation is also here in certain requests. Next algorithm is called C-look. It is also a version of C-scan where arm only goes far as the last request in each direction, then reverse the direction immediately without first going all the way to the end of the disk. See, the direction is same here towards the highest number. So we'll start from 53 and goes towards the highest number, serving all the requests till 183, and then immediately we reverse the direction before going to the end of the disk. So we can be here immediately reverse the direction from 183, and after that reaching to the lowest queue element called 14, we then reverse again and serve the remaining. So we cannot move to the either of the end of the disk here. So this is the C-look. The advantages of C-look is minimized head movement, improved throughput, no reversal overhead because we cannot move towards the end, both ends. Disadvantages are it sometimes gives potential unfairness to the elements in the queue, risk of starvations, inefficiency for bidirectional workloads. Now, how will you decide which schedule algorithm is good for our condition or the particular scenario? So these are some good ideas. Says SSTF is a common and has a natural appeal. C-scan and scan perform better for systems that where a place have a heavy load on disk. Performance depends on the number and types of the request. Requests for disk services can be influenced by the file allocation method also. This is very important. The disk scheduling algorithm should be written as a separate module for the operating system, allowing it to be replaced with a different algorithm if necessary. So either SSTF or loop is reasonably choice for the default algorithm here. So this is the end of the session. Thank you for joining today's lecture on disk scheduling algorithm. Stay tuned for our next sessions, where we deliver deeper into advanced topics in operating systems. So as a conclude, it is essential to understand that the choice of disk scheduler depend upon the various factors such as workload, characteristics and system requirements. Thank you.